Hello everyone, my name is Alexander Zelenin. Oleg.
Hello, my name is Oleg.
Today we will try to solve problem called climbing the leaderboard. I will be like the guide and Oleg will try to solve it in the most efficient way. To be honest, I had solved this problem in past. I just like this one. So just want to walk through this task. So let
Okay,
me
cool.
just increase the size of text because some people was asking to do it like this. If anyone want to read by his own, just set on pause. I will explain it by my own. So we have some
So
leaderboard.
Zav, I think my team viewer just fell off. Why don't you continue and I'll try to
Uh,
log back in.
okay. So we have a leaderboard, and on that leaderboard, every user can be only on one. Multiple users can be. Man, stop, please typing.
Yeah, sorry, my keyboard shortcuts for my desktop are being
Yeah.
transmitted.
So for multiple players can be on the same place if they have the same score. So for example, if we have 4 players with a score like 190, 90 and 80, these players will have ranks of 1, 2, 2 and 3. So 2 players in this case will be on rank 2. We have a new player, Alice, and she playing multiple games in a row. On first game, she achieved score of 70, on second game 80, and then 105. And we will need to display their position on our leaderboard after each game. So like when she get a score of 70, we will need to display that she on 4th position. When she achieve the score of 80, she share the 3rd position with some another player, and we display like 3rd position. And after she reach a score of 105, she go to the 1st position. The important thing here is that she goes only like up on leaderboard. Even she get a lower score, it will not affect she's position on leaderboard. So our input is like 2 arrays. First array is scores of the users on the current leaderboard. The second array is results of every game of Alice. So like she play a couple of games and each result is displayed in this second array. And we will need to display place that she achieved after each game from like this second array. Is the task clean enough? Clear?
Yeah, for me so far.
Okay, maybe you can try. So we have some sample inputs.
Could you just scroll up? I want to look at the constraints real quick.
Yes. So our constraints is n. So we have a number of players on leaderboard up to 200,000. The count of games played by allies is again up to 200,000. Each score is from 0 to 1 billion. Okay? Yes, it is for the players and for the games of allies. It's the same. The existing leaderboard scores is in descending order. So looks like scores is ordered already, which is nice. And allied scores is in ascending order. Okay, all schema for today will be next. First, we will start with discussing algorithms, its complexity, and so on. And then we will jump to writing code. Then we will test it, debug, and like get result. So
What
you
is
can.
that subtask that it had?
It's not a subtask. It's like we have different constraints. If you will write not optimal algorithm, you will still able to get some score.
Mm-hmm.
But just think for constraints like we want to solve it like for 100%, not only for part of that.
Okay.
So we can draw something here. What ideas currently you have how you want to solve this?
Well, I would iterate over Alice's scores.
Okay.
And I would compare it. So I'd compare the first score to the. I'm almost thinking I want to reverse the sort order of the. Well, we don't need to because we can just index. So I'd compare her first score to the last score of the leaderboard.
Okay.
And we can figure out a rank based on the array position. Based on what is it, M? No, N.
Okay.
N. So the last score would be position N.
But
And
it will
if
be not. It will be not position n, since
N
a
minus 1.
couple of
Yeah.
players can be on the same position. For example, if there will be 100
Oh,
players with score of 50, and like there is no other players, all of them will be on first position. So
right.
you cannot rely on
Uh-oh.
index.
Uh-oh. So interesting. So we have two arrays to iterate there. I mean, we'd have to almost generate a third array to store. I mean, that's one possibility. Is we could generate a third array from the leaderboard to. So I guess we could approach the problem backwards.
Okay, which array you want to generate from the leaderboard?
Well, okay. So maybe, well, this is my first attempt, but I think there's a way to optimize it. But basically, create a new array with objects representing both the score and the rank for the leaderboard. That way, we can group duplicates. And
Okay.
but then we have to go through the array twice, which isn't a problem, right? Because that's only 2n, which translates to n.
Score and place, right?
Yeah,
Okay.
maybe something like that. Or at least just to duplicate the array. That's the same kind of concept.
Just want to mention one time that when you are solving problem like this, it is quite important to find information that are not valuable to you. So, for example, in this task, we need only to display positions of allies game. We don't need to do anything with scoreboard after this like script will do something. We don't need any other position. We don't need the caching and so on.
Right. But the reason is because we don't. If we start with her, I suppose if we start with her highest score, then we can start comparing it right away to the leaderboard. And if she gets inserted in the middle of somewhere, we'd have to offset the leaderboard rank by 1. And if she gets put in with an existing score, then we just use the same rank. And so that would write. So we'd iterate Alice descending and leaderboard descending.
Okay. Okay, so both of them will go in descending order, right?
Yeah.
And what you want to do?
So instead of, so we'll take Alice's top score and iterate ascending on the, descending on the players, going, counting the rank 1, 2, and deduplicating it.
Let's get some example. For example, we have like 5, 25, 50, and 120. And we have scores of 100, 100, 50, 40, 40. I will try to find something better than drawing it in paint with mouse next time, but for today it's fine. So with what you offer, let me change color to the green one. We are going for the last number, so we're going from the last one, and we compare it with which one?
So we start also in descending. So we compare 120 to 100. So that's bigger. So now
So not in descending, since the array itself already sorted in descending order, then maybe
right.
we need to like go in ascending one.
Well, I meant descending by value, but yeah, ascending by index.
Yeah.
Right. So we already know that 120 is the first one, so we put 1 as the result of, but of course we'll have to reverse that array at the end.
Yep.
So we got 1. So then when we go to 50, we know it's not bigger than 100. So we're just going to have a counter of what the last rank was. So that's 2 is for 100, so we skip both hundreds. Then we reached 50, so we know 50 is now going to be number 3. So now that's going to be 3.
Okay.
So then we get to 25. We know 40 is going to be 4, and we're going to skip those. And when we get to 20, we know that 25 is between 40 and 20. So now we're going to end up putting that in as place 5.
Okay. Place 5.
Yeah, and we just keep going like that, keeping a counter of what the last rank was.
So
You know.
5. Okay. And what we got
Exactly.
here?
And then we reverse the final array, and we're done.
No, for the last one, what will be the value?
Oh, so let's see. So we've got 5, 6, 7, 8.
We have 8. Okay. And then we reverse the array and got the result, right?
Yeah.
So, but thing here is...
Hold on, I might have miscounted something. Let's see, 1, 2. No, it might be right, but
the proper answer will be 6, 4, 2, and 1.
sorry, I might have miscounted something. So let's see, 120, 100, 50, 40, 25, 20, 10. But how can it be? So we're not actually counting her scores as affecting the leaderboard.
We can do it like
Of
this.
course, because her
So
scores do not
this
affect the
is...
leaderboard.
Yep.
Right. Because we're
2,
going backwards.
3, 4, and 5.
Of course, yes. That makes sense. So we kind of ignore her previous scores and just use the existing leaderboard scores for that. Because her future scores wouldn't have gotten on the board. Her higher scores wouldn't have gotten on the board yet and wouldn't have shoved the ranking down. You're right, good catch. Yes.
Okay, nice. So with this approach, what will be space complexity for this task? Just to remember for viewers, space complexity is how fast memory changes over time depending on the incoming variables. So we have two incoming variables, is Alice score and current leaderboard.
Well, the output array will be about the same size and even rate as the Alice array. So it would be a complexity of the size of Alice, which I believe is
Okay.
M as in Mary.
Let it be M. Okay. No other structures, anything else? Looks like no. Okay. And for time complexity?
It will be, I believe, N plus M, because for every, we have to iterate over both of them completely. Maximum will be N because M, because Alice might be completely at the top. But, minimum would be M, and maximum would be M plus N.
Okay, M plus N. So we will go for the like worst case. So in worst case, yes, it will looks like that. So this looks like an optimal solution. I had used this task when I interview a couple of people, and you are pretty well with that. You will really quickly find a good approach to solve it. So let's try to write some code. Let's go to the code. Let's take a look what we have here as prepared code. We have climbing leaderboard function with two objects, scores and allies. And in the end, we need to return an array. Okay, nice. We don't need to print anything, so we just receive two arrays and we return an array. Okay. I'm just thinking how to put it somewhere near to be visible, but okay. I will just switch between windows if it will be required. Will you able to write it by your own?
Let's see. We'll find out. Let's see. Or just feel free to correct me if I make a mistake here.
Okay.
And then
So we're starting
usually
with
it's my
creating an array, and we can return it like from now, since
right.
okay, now we will need to fill it with something.
Yep. Now, can I just put a function here?
Yeah,
I
you
believe I
can
could just do
use arrow function. Yes, like this one.
Is it a key value or value key?
Value key.
Equals like this.
Yep.
Cool.
I just
And
want to
I believe
answer the question we have in chat. Yes, I plan to do lead code styled interviews, but I will need to check later on if it like possible to stream them, because it might be prohibited. I'm not sure right now about this one. Please continue.
Okay. So let's see. I think we need a counter.
Maybe it will be easier if you will go with an array, since you will want to skip some results.
What do you mean?
Sorry. Will be easier if you will go with a simple cycle instead of going through each of them. Since you had mentioned that you want to skip some of values.
Mm-hmm.
No, sorry. Yeah, it's alias. It's alias. For alias, you will not skip anything.
Oh, okay, thank
Yeah,
you.
so sorry. My mistake.
Oh no, that's fine. So and then we've can we bring up the drawing again real quick?
Yep.
So we need to actually first reverse Alice. Is there a array.reverse function in JavaScript?
Yes, exactly like this.
Perfect.
But you need to assign it since reverse will return a new array. Like, yep.
Okay.
I'm not sure exactly will it return new array or not, but for now that's fine.
Yeah. And okay, for and we could of course optimize it by using a pointer and going backwards, but we don't really need to.
Yeah, that's doesn't change anything exactly. Anyway, it
And
have
we
complexity of just same as alias length. So
probably want a last rank here. So
maybe you can start
I'm
with.
just gonna
Okay.
I'm just gonna make just some scratch code.
Yeah, I also like to do like this with some cycle without condition and then change it.
Yeah, and then let's see. Last, we'll just make this just to make it.
Okay.
I'm just making very rough code,
Yep.
just because again it's JavaScript and stuff. So let's
Yeah.
see. Let then the rank will be last, or I would actually say just increment last rank.
Yep.
Can we append, or is it like
Push.
this?
No, it's
Push, thank
called
you.
push.
And that pushes it added to the end, right?
Yep.
Cool. Okay, so that looks good for one round. So we need let's see, while. So now I'm gonna just take this out here.
Let's get to our schema. So in this example, we start with like 120, right?
Mm-hmm.
We compare it with 100.
Mm-hmm.
Our score is higher, so we increase last rank to 1 and push it. Everything is fine, right?
Mm-hmm.
Then we go to next value, to 50. And we will start with, again, with this one. But when we will go to the next one, you will still increment last rank, which you told we don't want to increment last rank at this step.
Right. Yeah. So actually, I want to undo my. I actually like that last score there. If I lost this last score, so let's make another one. If last score equal sorry, this will actually be something like this equals compare score. then continue, right? And then here we can say last score equals compare score.
Sorry, why you compare score is our current alias score, right? No, or
No, it's
current
the
is
current
value.
score we're looking at in the, so this is Alice value.
Okay, okay, where
So that's
you
actually a good, let's do this just to make it clear. Alice value.
Yep.
And if Alice value, right?
Yep.
And instead of compare score, I don't know if there's a queue to just rename them all, but let's
You can use
score.
Control D. Control D.
Oh,
Just
thank you. Control D.
one more time.
Score value. There we go. Very nice.
We have
And
compare
then,
score one more time here.
oh, okay.
Yeah.
Cool. And then this one, I'm just gonna.
You need to create a variable for last score also.
That's right.
Maybe better to set the null or something like that.
Yeah. And then make it, or even negative. Is there negative scores?
No, by constraints we have it from the 0. 0 is minimum 1. But the null is fine, like you can
Okay.
compare. Like it
Okay.
will be not equal since you compare types also with 3 equals.
Yeah. So then, so that takes care of the duplicates. And then we want to break here to break out of this while loop, and we don't really care about the other one.
What if alias score will be always less than score value? This cycle will be unlimited.
That's true. We also need to check, of course, the last score index.
You can write this check in the while instead of true.
That's right. That looks right to me.
Okay.
Okay. Am I missing anything?
One comment about this part. For example, allies will have score like 125, 120 in the end. Okay? We start with 125 and you got score of the first place, right? Then you go with 120 and you increasing the rank by 1. So you will,
Yes. Yes. That's a
in
good
this
point.
case, it will be 2, but it should be still 1.
Right. So interesting. So, okay, here we go. I know. Yes, yes, of course. Oh, come back.
Before you continue writing, can I just pause you for a second and ask
Sure.
you when you want to increase the rank itself, just to make it explicit?
Right. So that's what I'm putting in right here. Is I want to actually take it out of here and put it in this statement instead. If score value less than last score.
Okay.
Actually, and we're We can even have a non-equals here.
And maybe you need to modify the last score itself.
Yes.
Like since this score like change every
Yes.
time.
Yes, of course.
I
I think right
mean,
here, right? No. What am I missing?
let me put it here. Since you need to modify last score every time the cycle go, not only once.
Well, if the score value does not equal score, and it doesn't really matter here if we put it in, it's just more of a, because this will not change here if it's equal, right? It'll be the same value. So just for clarity, I'm putting it here, but yeah, I could easily
Yeah. Okay.
go over there.
Let's do it like this. Fine.
And then okay, what
So
else am I missing?
let's take a look at our algorithm. So how it will work. So we are starting with 120. We have Alice value of 120. The score is the index is 0. We're getting the first value, which is 100. It's not the same. Then score value, which was 100, is not equal to the last
Maybe
one.
put an extra equal sign there.
We increase the rank. Why? Like we need to start with the rank, with the first rank, not with the 0, 1 anyway.
Well, what if this first one is 0 and
Sorry?
not null? Can we have a score of 0?
Yes, we can have a score of 0.
So we want to just compare it to not null, right?
Yes. So we increase our rank to 1. We set the last score of 100. We check that Alice value of 120 is higher, and we push result of 1. We break the while. We go to next value. The next value is 50. With the 50, we getting the same index initially, which is 100. We check it with the 1 second.
Oh, we're not incrementing last score index.
Лена, убери sorry.
Yeah, we're not incrementing last score index. I forgot about that.
Yep.
That would help.
Yep.
And we can even just do something right here.
Do we need to do
plus
it
plus.
every time? Do we need to increment last score index every time?
Well, I suppose so, because this is the inner loop, so we have to.
But if we if our value is passing everything, then maybe we don't need to increment our index. For example, if all our scores will be higher than the highest one.
Yeah. You're right. So in that case, we only do it here.
Okay.
Yeah.
So let's go and see what will happen next. So we have the score of 1, then we go to 50. With 50, we will check it with the last score. It's not equal with last score, so everything is fine. Then we sorry. We're comparing the last score, which is the same to the current score.
Is it?
Yes.
We didn't get past the hundreds yet.
The last score was 100. Since when we compare it with 120, it was 100. We set the last score. Then we break the cycle. We go again, and last score is the same to the current score. Since the index is the same. Maybe instead of last score, we can store last score index. What do you think about this? We have last score index generally. But we doesn't have the current score index. Maybe let's rename it from the last one to the current score index.
Yes.
And
last score could be last score value.
Yes. No, we can create a last score index, which will be also 0.
But aren't we only going to use that to look up the last score value anyway?
Because
we know it's already it's already sorted. What we care about is whether we have a duplicate or not.
Sorry?
Well, the last score index will always be 1 minus the current score index, right?
No, since we can compare with the same score all the time. Like, for example, if we have result of 125 and 120, the last index will be 0 for both of these cases. The current index will be 0 and the last index will be 0 also.
I guess what I'm saying is I don't know why we need the last score index. It seems unnecessary. Well, how would you use it?
Okay, let's get rid of this. We have right now next problem. We store last score, which is 100, and current score when we go, also 100, and you just skip it because it's the same as previous one.
Yeah, but we're not interested in it because...
But here is the case one more time. We have a last score of 120 and 125. We have, let me pick some another color. We have our scores in table 100, 100, and something after this. So when you go with the first number, you compare it with the first one and got 1, and the last score will be 100, right? After this step. Last score is 100. Score values is equal to current score index. Current score index is 0, right? On a next step, when we try to compare 120, we go inside and our index is still current index is still 0. And the last score is 100. So the score will be equal to the last score. So we will skip this value until this one and until this one. And we will came to this position. Instead of putting it here again.
Yes, I see what you're saying. Oh boy, yeah, for sure. So maybe, interesting. So maybe we need to push this one up higher and start with the last rank of 1, perhaps, and move this up here. And then here we could just have, we can get rid of this because this is not, and we can move this one. Whoops.
Mm-hmm.
And this one is now unnecessary, really, because, yeah, we don't really care about that.
But how you will skip the same values then? You don't
Well,
need to increment rank if... you will not increment because of this will be the same, right?
right. So the question is, yeah,
Maybe
because
let's
if as
test our
long as it's
code.
longer, yeah,
Let's
it's
let's
looking
run and
better.
see what we have here.
Yeah, see where we messed up. No.
So by some reason we have in output only 3 results instead of 4 1. And also we have like wrong value here, and we need also revert the result.
Yeah. So definitely a problem.
Maybe let's go take a look at what we have right now and try to write it from the scratch without try to debug what we have here.
I just want to add one more thing here. We need to result reverse.
You can do it. Sorry.
Oh, right.
Yep. But anyway, even with the reverse, we by some reason doesn't have enough values, so we doesn't have the last answer.
Mm-hmm.
And like even the second one, we got the 3 instead of 2.
Mm-hmm. You want to rewrite the whole thing over from scratch?
I
It's a very simple
presume.
code. I'm sure we can figure out what exactly where we went wrong, right?
Yeah. Okay. We can do it like that. Let's go then one more time again with what we have here. So maybe let's write down here our example. So we have allied scores of 120, 50, 25, and 5. We have our scores of 100, 100, 50, 40, 40, 20, 10. 40, 20, 10. Okay?
Mm-hmm.
So this is like first place. This is like second place, third one, fourth one, fifth one. Yep. We go with 120.
You know where we messed
Initiate.
up?
Yep.
We forgot to put if Alice value possibly something like this because
Yep.
we're missing the equals values.
Yep.
Well, we got everything but the last one wrong. What about the second test case? The
Um,
test case 1. So we're just missing the 6. And what about here?
the same
Yeah, we're just
here.
missing the last one. So that's all we need is to finish off the last one. There's something going on with the last
Yep.
the
Like
last value.
what if we going out of our cycle without breaking it?
Yes, exactly. So we need to have maybe a. So I would put like a broken, let broken equals false, and then broken equals true. Something like that, or found. What do you suggest? Is there a cleaner way to do that?
I think we can just add a condition after a while. So if we go through like all the scores and we did not found a value, we can just push our last rank, and that's all. And
Okay, so but we need to figure out if we added a value, right?
But we can do it like by the condition, like if we if current score index greater or equal, generally we can just compare with equality, but just for safety we can do it like this. We can add just a value of current last rank that was calculated here and take a look what will be here.
Well,
So,
I'm thinking before we submit it, as you scroll up, I'm wondering, back to the code, I'm just wondering if it's possible to get here and have this incremented. No, because if it was broken, this would not get incremented.
Yep,
Okay.
exactly.
Okay.
Exactly like this.
Cool.
So
cool.
we can try to submit our code and see how it will works.
Yes.
Great. So we successfully solved this one. Let's go over code one more time and like write down complexity that we got from this, like space complexity and time complexity. Space, like we had initially assumptions of OM complexity for memory and OM plus N for time. So time complexity.
So my screen is not updating, so I'm just gonna. You go ahead. I'm gonna rejoin.
Okay. So for space complexity, generally we store only one array, which is a result. Also, we make a reversal of alias, but since we like rewrite it, it doesn't store anything as additional. And the other things is just a simple variable that doesn't change the value. So as it was presumed initially, we have space complexity of alias length. And for time complexity, I will not calculate the reverse of the array, since we can do this with just a cycle with reverse indexing. But generally it's the bad thing that I didn't like with TeamViewer, that it's just spoil the password to everyone on the stream so anyone can join.
Oh well, okay.
I will reset it right after the end of stream, but like okay, so we don't count on this one, and for time complexity we're going through alias ones, and we are going through the scores, and it can looks like we have an array inside of another one, but generally we can go through this one only once, since we incrementing our score index, and when it reach out, we are left with just this push, and that's all. So space complexity, as it was presumed initially, will be like alias length plus scores length. So I presume that we can go for some micro optimizations. For example, I think I had done this before. If our score changes a lot, like for example we have score of 120 and then we have some small score, we can make something like binary search, so to like found values a bit faster, but in worst case we will still end up with the same one, so there will be like no big difference. Like we can from the start remove duplicates or something like that, but again from the time complexity we will not get a more optimal solution than this one in worst case. In some optimal cases we can get something better, but in worst case it will be like this. So looks like we successfully solved the problem. Thank you, Alec, a lot for participating today, and have a good day.
Yeah, thank you. This was fun.